Alright, welcome back. This week is the wrap-up of the week 6 trig stuff that I did in the workshop in week 7. I'll just briefly go through those for us. So, express each of the following terms of an acute angle in terms of an acute angle. So in our diminishing triangles, where we have, let's do a few of them. So we have this kind of thing going on, and so on and so forth. And so that represents all of the possibilities. Now, if we think about one in particular, let's just grab the 3060 for this one. So this represents the angle counting around 1 to 4 lots of pi on 6. The bigger angle has the smaller denominator, 4 lots of pi on 3, and we know that this has an equivalent in the first quadrant. So this represents an acute angle, and it's just pi on 3. Okay, so it's an equivalent, but this particularly nominates the y. So in this one, what we're looking for is if we had a y that was negative, and we have a y that was positive, how do we make them equivalent? Okay, how do we make them equivalent if that's a plus? So that's what we're doing here. Alright, so for sine 120, we've got two 60-degree angle triangles. In actual fact, that's the one that we're interested in, sine 120. So we've got a count of 1, 2, and then 3 is pi. So the count of 2 brings us to this one here, and this 120 is this angle here. So theta equals 120, or 2 counts of pi on 3. But that's only locating what's happening there. So sine 120, this is representing y. So this question's saying what's an equivalent of y, a positive y, using an acute angle. So all we've got to do is look to this one, and we can clearly see that an equivalent angle is the 60-degree angle. So an equivalent of sine 120 is in fact sine 60. It's an equivalent because the y's are both positive, and we can check that with our calculator to see if we get the same number. So if we get the same number, we'll know that they're the same thing. So we're in degrees, so I can just put in 120 sine and 0.866 and 60 sine and 0.866 is the same number. You can see they're both the same number. Okay, so they're an equivalent. One is expressed in terms of its, but they change depending on whether it's cos or what have you. Alright, so that's that one. So the next one is cos 210. So cos 210 viewed as a diminishing triangle is past 180, it's past pi. It's not quite 270, so it's around about here. And it doesn't matter that it's not an exact value because we're looking at it. It's the concept. Now what's cos after? Cos is after this part, x. Okay, so x in this case here is a negative. Okay, x is negative. So to use the diminishing triangles, we would have one of these in the first quadrant. And the problem we've got here is that x is positive. So if we take the 180, pi is 180, 180, 200, it's 30 degrees. So we're going to go for 30 degrees. 180 plus 30 is 210. So the problem here is that if that's 30 degrees, our x is positive. So how do we make it an equivalent? In other words, our cos 30, although it's the same length, it's a plus. It's a plus. So how do we make it equivalent? Well, the only thing we have to do is make it a minus. So therefore, cos 210 is equal to minus cos 30. Okay? Now we know from our work that if we count around 1, 30, 60, 90, 1, 2, 3, 4, 5, 6, 7. That's 7 pi on 2. 7 pi on 6 is going to be equal to minus pi on 6. Okay? It's going to be equal to minus pi on 6. And we know that the cos of this, I should just make sure the cos is in there. They're the same. Oh, now the minus is not in the angle, so I better just correct that. Just kind of squeeze things up. So minus cos pi on 6. So if we take those, we know that that's root 3 on 2 minus root 3 on 2 minus a half. And this one's plus a half. So putting the minus in the front means that we'll have the same thing. Okay, and it says if possible evaluate without a calculator, so we can use the calculator to do that, either in degrees or in. So 210 cos will be minus 0.866. 30 cos is plus 0.866. So now they're the same. So finding your equivalence is just using your exact values trig ideas, and even if it's not an exact value, we can still work things out. So sine 240 is looking at y at 240. Now 240 is past 180, pi is 180, and 180 will be 60 degrees on. So it's the 60 degree triangle. And its acute equivalent, its acute cousin, is here. Okay? So that's our theta, our base angle, and this is our count. So 1, 2, 3, 4 lots of. Now 60 degrees is pi on 3. Now it's asking for y again. There's our y, so it wants this one. So clearly the y is negative. But up here, the acute angle, the y is positive. So what that means is that our sine 240, our y at 60 degrees is positive, so we have to make it a minus sine 60. Okay, because the y's are the same proportion, and it's the acute angle that we're interested in here. So that's the acute angle that we're interested in. That's sine 240 expresses in terms of an acute angle. Alright, so for tan 300, we only think about the equivalent association. Now tan is rise over run. So we'll have to look at rise over run at 300. Now 300 is all the way around here. 30 less, 60 less than 360. So it's another one. Okay, so it's 60 less. Okay. So fairly straightforward. So the evaluations are going to be root 3 on 2, aren't they? If we evaluate them. Okay, for cos it's x, and x is root 3 on 2. So it's minus root 3 on 2. There's our minus there, that one there, and minus there. So for this one here, this is again minus root 3 on 2. So 60 here is root 3 on 2 minus, and a half there. So tan is y over x. So the equivalent, if we think about the angle going all the way around, now there's two ways to evaluate this. We could use the shadow, the internal angle. So this is 1, 2, 3, 4, 5. So that is 300. which is 5 lots of 60 degrees, 5 lots of pi on 3. This one in here, this angle in here, is just pi on 3. Okay, now the tan, we need to be careful here because here this is negative and this is positive, so this would be minus root 3 over 2 divided by half, which is minus root 3 over 2 divided by half, which is minus root 3 over 2 times 2 over 1, which is minus root 3. So we can see that the tan for that, now for the other one, the rise over the run is root 3 over 2 over half, but it's positive. So it's okay for us to use the tan of the small angle. We can still do tan of 30 degrees. It's just that we, of 60 degrees. It's just that we need to minus it. So tan 300 is equal to tan 60, and it's minus root 3. Okay, so you can check your 60 degrees for that. Alright, so exact values trig is helpful. It's very helpful. Alright, so in these examples, what we're looking to do is just express them in terms of bigger angles. So our 180 point is here, pi is 180. So, it can be expressed in terms of 180 minus theta, there it is. Or it can be expressed as going on further by some angle. Okay, this one here is all the way at 360. 2 pi equals 360. So going back some angle. Okay, going back some angle. The other thing I could have done up here, which I didn't do for the tan, is I could have expressed this as a negative angle. I'll leave that for the moment. Alright, so just a little example here of undo. Okay, sine alpha equals 0.53. So what's the instinct? What's the intuition? Take sine to the minus 1 on both sides. So there it is showing up on the right hand side. And then just using your calculator. And then you can work that out in terms of either adding the angle theta to 180 or subtracting it from 360. Okay. So sine has two particular values. So sine, remembering that sine represents this part of the triangle. See that they're the same. For a given alpha, they're both negative. Alright, so solve the following for 0 to 360. Where is sine y half? In other words, the smaller angle, so the association, the proportion, and the polarity, or the plus minus. Y is a half, negative, where? Well, the small triangles. Both of those represent negative a half. Negative a half. So this one here, you've got to come all the way to a count of 11. Here, you've got to come to a count of 7. So this angle here is 7 lots of pi on 6. This angle here is 11 lots of pi on 6. So 7 lots of pi on 6 and 11 lots of pi on 6. That's that count around. Okay, so those two are solutions for negative a half. Alright, that's also 180 plus 30, which is 210. If you want to try it in there. And that's 360 minus 30, which is 330. 330. Okay, so what we want to do is just check that with your calculator. So if we do the sine of 210, we get negative a half, that's a tick. And then if we do 330, the sine of negative, we get, what did I do there, 30 degrees. Oh, I put in 300. Sorry, my bad. And I'll panic a bit then, didn't I? Same number. There it is there. There, forget that one, that's a mistake. So minus 0.5. So for that domain, there's two answers, 3, 210 and 330. So the exact values trick continues to be in your favour. Okay. All right, for cot, it doesn't lend itself to being analysed in terms of exact values trig, but all we need to do is consider when is cot or when is tan, because remember this is tan theta, so 1 over 10 is minus 1.58, and where is rise over run? So rise over run's positive here, y over x. Here they're both, one's a positive and one's a negative, so it's negative there. Here they're both negative, so that's a positive, and here one's a positive and one is a negative, so there is a negative. So those two results exist there. This one's short of 180, so it's 180 minus whatever the angle is, and this one's short of 360. So it's just a way of getting both of those, because we're told 360. Sometimes you're not told that. So to do cot, undo, our instinct says undo. Okay, so we've got cot to the minus 1 of cot theta, and cot to the minus 1 negative 1.58. That's undo, so therefore theta is equal to, so remember that they are in degrees, so we don't want to overcomplicate things. I feel as though maybe these are a little bit complicated. Your intuition should kick in. If you can't see it intuitively, maybe it's the wrong thing. So we better put this into radians and say 1.58 minus, and then let's go and get the cot of that second function, cot, and so we get minus 0.56 in terms of radians. Maybe we better check degrees. It's given in degrees, so maybe I've done the wrong thing there. Alright, so we'll just clear house. Okay, we'll just clear house, and we'll say 1.58 minus into degrees, second function, cot. So minus 32 degrees. Okay, so that looks about right too, doesn't it? Minus 32 degrees. Now that's only one. Minus 32.8 degrees. 0.33. Now, in this one, this means that this is correct. It's being expressed as a negative minus 32.33, and there's nothing wrong with that. Okay. The other thing we can do is take the 360 and minus. Okay, the 32. Now it won't be minus and minus; it'll just be minus. So 360 minus. Okay, so let's do that. Your intuition has to match the reality. So minus 32.33. 327.67, 327.67, which will approximate to 328 degrees. So that's the 360 minus 32.33. Okay, now we didn't take the minus of the minus. We took, in effect, we took the absolute value of that. Okay, so that's one solution. The other one up here is 180 minus. Okay, so 180 minus 32.33 is 147.67, which will approximate to 148 degrees. That one's 180 minus 32, and again, the calculator will give you this calculation in terms of a negative. So just be mindful of that, okay? It'll give it as a negative angle. So these are equivalent, so you can put them in. you can do the cot of this, and it'll give you the same thing. Okay, so just check that out yourself. All right. This goes to realizing that there's loops. So we start off and go around once, but what happens if we go again? Oh, that's like going one cycle. There's your 2 pi, 360. Okay, there's your 360. Then what happens if you keep going? We've got 2 lots of 360, and so on and so forth. It can go on many, many cycles and many, many rotations. So often it's just a case of subtracting the number of multiples and recognizing them in terms of their exact values. Okay. So cos 780, 360 twice is 720. So if we just do 780, take away 360, just to show we can do it by hand, to 420. Oh, that's much bigger than 360, so we'll do it again. Take it away. 60 degrees. So this is the equivalent of going around twice and landing. So off you go once, twice, and landing back on a 60-degree triangle. So theta, hypotenuse, root 3 on 2 half, and theta is 60 degrees, or the bigger angle has the smaller denominator in radians. So in actual fact, that's an equivalent, and the equivalent is, what's cos? X. So cos 780 is equal to cos 60, which is equal to x, and x is a half. You can check that with your calculator. Okay, sine 495, we'll be looking at y. So we'll do it 495 minus 360. So that'll be 5, that'll be 3, that'll be 1, so 135. So 135 is 4590. It's this one. 1, 2, 3. So it's actually this one. Okay, 1, 2, 3. So it's been around once, and it's come back and landed here. And the sine represents the y, and so its equivalent is sine 135. 135, and that is equal to 1 on root 2. Or if it's rationalised, root 2 on 2. Okay, so we've done it without the calculator. So you've just got to think those things through in terms of their plus or minus and where they land. You'll notice I'm being very particular not to use the language quadrant because I don't think it's important. Okay, so I'll leave that for you to ponder. All right, so sometimes we use radians, and I've done this with the unitary method. This is taught in like year 8 and year 9. It's very cumbersome. I don't encourage you to do this. I encourage you to do the white sheet. But we know that pi is 180 degrees, so we set this up for 2 versions. One where we divide by pi, and one where we divide by 180. So if we divide by pi, we'll get 1 equals 180 over pi, and this is radians. Okay, if we divide by 180, we'll get pi on 180 is equal to 1, and that's in degrees. So now that we've got the unitary method, we know what 1 degree is, and we know what 1 radian is. So if I want to get 60 radians, I just multiply both sides by 60. If I want to find out 35 degrees, I just multiply both sides by 35. And whatever's left over, that is our unitary method. So for example, 2.57 radians is going to be 2.57 times 1, 180 on pi, 2.57. So that'll give you 2.57 is equal to 180 times 2.57 over pi. Very straightforward. Example, 60 degrees. Just multiply both sides by 60. And this one will be 60 times pi on 180. The noughts will cancel. So we get 60 degrees is equal to, 6 goes into itself. Oh, look at that, pi on 3. As if we didn't already know that. Okay, so the unitary method's useful, but it's better that we just learn our exact values and go between them. All right, so so in this particular case, what this is saying, if you look carefully and just notice what this is saying, that this arc length, R, is the radius. Oh, so that arc length there is the radius. Okay, and when that happens, you get an angle of 180, 1 radian. Okay, so that's all that happens. Okay. Convert 13 degrees to radians, if we must. Okay, 13 degrees, so we're going to multiply, remember we had 180 divided by, if we've got 1 degree, that's this one here, so pi over 180, so it'll be pi over 180 times 13 equals 13 degrees. So that's what our unitary method tells us to do. Okay, and so we get 13 pi, 13 lots of pi over 180, and if we put that into the calculator, we'll get a decimal that approaches 0.227. 2.3 radians to degrees, so this time we have 180 over pi is equal to 1 radian. So we're going to multiply by 2.3 both sides. Okay, so 2.3, so it'll be equal to 2.3 180 over pi, and so that will approximate to 1.131. That's less than that. 131.780. Okay, so it's possible to do the hand calculation using the unitary method. It's not important on one level, but we can go from there. All right, so the exact values you know, we would hope you would know. Okay. All right, so you can do that for the regular ones if you want to make up your table, but I haven't taught you to do that. You know, all of these guys here, I've taught you to do that through recognition. I've taught you to do that through recognition. All right, so find sine and cos. So again, by recognition, association. Oh, hang on, find 2 decimal places sine. Well, you're just using undo. Okay, sine to the -1. Oh, actually, that's not even that case. All we're doing is just putting that straight in and doing it in terms of radian mode. So let's put the calculator into radian mode. Okay, so there it is, radians, 2.33, and we just take the sine of that. So the sine is 0.725, so we'll round that to 0.73, that'll be good enough. Okay, 3.486, 3.486, and we want that to be 10. Still in radians, 0.358, which is 0.36. Okay. Alright, just make a note of that. If it's not expressed with the degree symbol, it's got to be radians. If it's just like a number, then that means it's the hint. Come on, guys. This one here, really, the bigger angle has the smaller denominator. So not even trying to think too hard about this. Y equals √3 on 2 for a unitary circle. 5 lots of pi on 3. 1, 2, 3, 4, 5. So here cos is still the same. It's a half. So equals a half. Okay, it's not difficult at all. For this one here, it's just a number. So we can see that there's a number. It's asking for a number of decimal places. It's telling us there's a pi, so make sure it's in radians. And remember that when we do it for 2 pi, there's going to be 2 locations where this is true. Okay, so where is sign negative? Sign's negative in this one and this one. So whatever angle this gives us, it's going to have to be plus or minus pi. So there's pi, so the angle will be there, theta plus pi. Okay, theta plus pi. And this one here will be 2 pi. So it's going backwards. So it's theta, so this one will be pi plus this angle. And this one will be 2 pi minus whatever this angle is. So when we get this back, we could get it back. So let's have a look at it and see what we come up with. Okay, so when we solve this, we're using pi's instead of degrees. So you have to watch the interval very, very carefully. Which interval is it? So if I put in my 0.734 minus, take the sign of this, it's giving it to me as a negative radian. Okay, it's giving it to me as a negative radian. Negative 0.6, so do 0.67 in radians. Okay, so now though, this is effectively this one, but what we want is effectively the absolute value of it. Okay, so let's do this one. Let's take the negative off. Just put that in the memory. Clear all this other stuff. So pi plus this one is equal to 3.811. 3.811. Oh, hang on a minute. I didn't solve for that. I just put that in. Sorry, I've made a mistake there. I need to correct that. Okay, so let's just correct that. This is an equation to be solved, but it's in radians. So we're going to have to take to the sine to the minus 1. Sine theta. What you do to one side, you do to the other. I beg your pardon. This is undo. So theta is going to be equal to that. So minus 7.34. Okay, so we put our calculator away. So minus 734 and inverse sign. That's better. So that's minus 47 degrees, but we're in radians, so let's change it into radians. Okay, let's do it again. 0.734 minus inverse sign. So 0.82. So now it's minus 0.82 minus 0.82. So now we're going to it's given it as a negative angle. So when we do pi, we're going to add that. So we're just going to clear the memory. We're going to put that in the memory, take the minus off, put that in the memory. Okay, so it's going to be pi plus, this is the first one, and we recall, and so that gets us to here, 3.96. We added the angles, you see? We added the angle. Just remember the calculator gives you a negative. The calculator is prone to give you a negative answer, a negative angle. That's what it's prone to do, but that's a negative angle. Okay, so just remember that it's taken the context in terms of a negative. Okay, negative theta. That's how this comes out of the calculator, as it did in the previous example. So for this one here, 2 pi minus. So we'll get 2 pi minus. So 2 times pi and minus, when we recall, 5.459 equals 5.459. Okay, so just be mindful of that. The calculator is usually returning negative angles. Okay, so we need to take that into account when we do these, whether they're in degrees or radians. Okay, that's enough for now, and I'll take that off, and I'll see you soon.